is if you are familiar with Desmos, and we're going to use that today. I really like it as a learning tool. Let me know, are you able to see my screen yet?
No, it's kind of a little frozen.
Kind of loading here. Okay. Let me check something on my end. I will be right back. All right, I'm back. Yeah, it does look like there's an issue, some sort of an issue here. Let me try one more time here to get this to share. Screen sharing is loading. Were you able to see my video without problems? Or did it freeze up? Marissa, I'm not sure if you're there, if you can hear me or not. I am not able to hear you at this time. Seems like something has happened to the meeting here. I'm going to throw that in the chat. I'm going to ask you to try exiting the room and coming back. Hey, Maris, are you able to hear me now? Hey, Maris, are you able to hear me? I can hear you great. I don't think you can hear me. Hello, hello? Hello, hello. Hey, Maris, are you able to hear me? Hey, I can hear you, but I'm not sure if you can hear me. Hello, hello. Good afternoon. Hey, Maris, are you able to hear me?
I can now.
All right. Sometimes there's a few technical issues in the beginning. No big deal. We'll make up for it at some point later on. But now that you can hear me, this is the more important part. I really hope this is where we ran into issues last time. I'm going to share my screen and hopefully you can see it.
I
That was the
can't.
issue. There it is. All right. So we're doing better here. Okay. So if you're seeing my screen, and this is the first problem that we have to look at today, the equation is 5 times 6 to the power of x. And then what I was asking you is if you'd ever used Desmos before. And the reason is I was going to have us look at the graph of this function here. Okay, so what I'm going to do is share that other window. I'll come back to this one in a moment here. Let's see if that loads. Yeah, so you're able to see my screen here and see this graph. Desmos is a really awesome tool. I'll throw that in the chat in case you want to look at that later on. But we need to know what's going on for the second graph. Okay, now notice I'm using y instead of f of x. Okay, that's okay. You can use y instead of f of x. The exponent though now is x minus 5. Okay, so what do you see here? How would you describe going from the red to the blue? The red to the blue.
Like the amount of the units.
Just
The
give me a word. Give me like one word or a couple words. Like keep it simple. You know, imagine you're trying to describe to someone that doesn't know any math. What word would you use to describe what's happening here?
being moved to the right.
Yes, it's as simple as that. And actually moved right 5 units. Okay, so I'm going to go ahead and snip this picture into our workspace here. And that way you'll have it in case you want to look at that later. I'm going to go back to it. A lot of clicks and movements here, but that's exactly right. So this part that's in parentheses here, okay, you're still seeing, okay, you're still seeing it. The part that in parentheses, that tells you that it's a right 5. Okay, so if it were like x minus 3, it would be right 3.
Yeah.
Is that reasonable?
Yeah.
Okay. Now, sometimes you'll see me do problems out of order. Okay, and there's always a reason for that. We're actually going to look at number 4 next. So this time the exponent is plus 3 instead of a minus. It's a plus instead of a minus. What do you think that might do to the graph? If
I
minus goes right, what would plus do?
go left.
Probably goes left. Yeah, that's a reasonable guess here. So I'm going to go back and we're going to look at that in the graph again. Okay, so instead of this x minus 5, I'm going to write x plus 3. And you can see that it's exactly what you said there. The graph went left 3 units. Now, if you're looking at these grids, they're not 1 unit now. It is, you can count here 1, 2, and 3. So yeah, it went left 3 units. Okay, so we can create a rule from that. We can say, okay, this is left 3. And so the rule, if we were to summarize here, is if it's in the exponent, x plus a number goes left, x minus a number goes right. Okay, and this would be like our reference sheet here for these problems.
Yeah.
Okay, now you learned at some point before this, you learned about quadratics, and that's probably where you first saw transformations. And there's many different types of transformations. We've only covered so far today right and then left, but there's also up and down, and that's what we're going to see next. Okay, so let's look at number 2. This +8, okay, this +8 right here. Okay, and we're always comparing this to the parent function. The parent function is just the part that I'll put in blue here. The parent function was just this part. So the +8 is basically off to the side or to the right of it. Any idea what that might do to the graph of this original function?
I'm gonna take a guess that it's up.
Yeah, it is up. And like what I often do is tell students, we'll go back to something like x squared. X squared is a U-shaped curve. And if it were x squared plus 8, you would know that this moves it up 8 units. Same thing applies here. Okay, now sometimes it's hard to see graphically. Let me go back to the other window here. So if I get rid of some of this and I go +8, sometimes you can't tell what's going on until you have some sort of a point to look at. Okay, and what I mean by that is like, well, we need like a known point on the red. So I'm gonna put in a known point, 0, 5. And then in the other graph, you're going to see that it's 0, 13. I'm going to zoom out. Okay. And you can see that 0, 5 is where the red crosses the x-axis, and 0, 13 is where the blue crosses the red axis, and they are exactly 8 units apart. So your intuition was correct on this one. Okay, so let's go back to the other screen. So this one is up 8 units. So if plus is up, you can probably see where we're going with this one. And for number 3, okay, number 3 is -12. What do you think the -12 does?
It's 12 down.
It's 12 down. Yeah. 12 down. Okay. So we can make a rule now about this. Okay. So when it's sort of off to the side here, I'm not sure what words would be meaningful to you here, but when we have a number, when we have something plus a number, we know that's going up, and minus a number, we know that that's going down.
Yep.
So you might be saying to yourself, I got it. I know this, no big deal. And then you see a problem like number 5. So number 5 has 2 transformations. And I'm sorry, do you need some more time to get this down, or do you have everything you want from this?
Yeah, I got it.
You got it. Okay. If you ever feel like I am speaking too fast or not giving you enough time to write things down, just ask me to slow up. But this one has 2 transformations. Okay. The first one, and the order does matter, is this going left or right? Is the x minus 2? Sorry, go ahead.
That'd be right.
Right? How many?
Right 2.
Okay. And then the second one is
Down 4.
down 4. Perfect. Now I'd like to give you a few more examples, but do you know if there's more problems than this as part of the assignment?
I'll check the classroom.
Yeah, why don't you check real quick, and otherwise I'm going to give you some practice problems like this, or we can also do some problems like we were working on the other day as well.
Okay, there is. I'm going to take a picture of them.
Okay, you can send that over by email or drop that in the chat, whatever is easiest for you. Let me know when you've sent something over so I can get going on that.
All right, sorry.
I know sometimes it takes a moment, first time around, but all right, got something here. Very good here.
Yeah.
Yeah, this is great. So this is more of the same, and it's the idea is that we're going to apply the same skills or same things we've been talking about thus far. So I'm going to snip in the first problem there, and we'll take a look at it together. Just let me know when you're ready to get started.
Yeah, I'm ready.
Cool. So this problem, the parent function, and always good to identify the parent function. The parent function is given. It says it's 3 times 4 to the x. So your attention should be to anything that isn't the 3 times 4 to the x, this plus 7. Okay. So notice this plus 7 is kind of off to the right. What does that correspond to if it's kind of off to the right? It's not part of the exponent.
Um, it's up.
Up 7. Yeah. That's it. There's actually nothing more to do on that problem. Do you turn these assignments in on paper, or do you work them out, I don't know, on this pad kind of thing where you type in the answers? What do you end up doing?
It's usually on the computer.
Okay. So you'll somewhere off to the right write the words up 7.
Yeah.
Okay. All right. Next one here. Again, I'll kind of draw your attention here. It's this minus 5. If you need me to scroll back up, I can, but let me know what you think for that one.
The right 5.
Yeah, and it's kind of counterintuitive. It's like, why is it right 5 if it's negative? I wouldn't spend that much effort trying to figure that out. Just realize that when it's inside the exponent, when it's inside parentheses, it's kind of opposite of what your intuition might tell you. All right, next one here. So this one, I'm gonna just highlight this +9. What say you? What does that look like in terms of a transformation?
Left 9.
Left 9, yeah. All right, this will be the last one on the page that you sent me. Definitely need to queue up some more problems here, but this one, it's got this -12 off to the right. What do you say here? Does this up, down, left, or right?
Uh, down 12.
Down 12. Yeah, perfect. So it's usually not too difficult when they're just one transformation, like up, down, left, or right. It gets harder when there's more than one transformation in a function, and that can be the case. Do you have some more problems that you'd like to send over for us to look at?
Um, yeah, I'll see. I'll see what else.
Okay. Let me know when you send that over. We can usually get through a lot more problems than you might think in a lesson, so you can always send over a bunch of stuff ahead of time, and just we'll get through as much as we can get through.
Okay, I sent a couple
Okay, awesome.
graphs.
All right, let me see here. All right, they must be in the wire. We'll let those come in here. Yeah, just waiting for those to come through. Let me know if they've been sent on your side. Yep, there they are. Got them
Okay.
here. Okay, so yeah, so you got quite a number of these. So we got some notes, some graphs. How do they differ? Okay. Right. All right. So here we go. Let me snip this in. And another option also is if you're comfortable, I'd be happy to log in and grab some of this stuff during the lesson time. But for today, we'll just keep doing it this way. So the first thing that it asks you to do in this problem is to graph the function. And they ask you to graph f of x equals 2 to the power of x. Okay, so this is considered an exponential graph. And what that means is that it's going to grow. It's going to grow. It's going to increase. Okay. I think the best way to make a graph is to use a table. And we'll do that here. So we're going to make a table where on the left, these are the x values. On the right, these will be the y values. We're going to start at 1, 2, and 3. We'll see if we need to go backwards here. But this means you're going to take this value of 1 and put it in for x. Okay, so if you need to, off to the right, you can be like, okay, what is 2 to the power of 1? Can you tell me that?
That's 2.
Just 2. Okay, how about 2 to the power of 2?
4.
4. And 2 to the power of 3?
8.
8. Good. So these are all ordered pairs. Like the first one is 1 comma 2, and I'll go over to the right and I'll put some dots there at 1 comma 2, and then there's an ordered pair at 2 comma 4, and then 3 comma 8. Okay, now what you should notice is that it's not a straight line that connects them now. And you probably saw that. Let me just scroll back up here on the graph here. These are not straight lines. They're smooth, they're curves, and they go up pretty quickly. All right, now we need a few more points to graph this. So these are the ones that get a little more difficult here. What is 2 to the power of 0?
0.
So anything to the 0 power is always 1. Anything to the 0
Oh,
power, doesn't matter whether it's 2, a billion, it's always 1. Okay. So that's another ordered pair here, 0 comma 1. All right. And then I won't ask you this one, but with negative exponents, 2 to the power of negative 1, that ends up being 1/2. We can spend some time talking about that. It may be today, but also perhaps in a later lesson. Negative 1 comma 1/2 here. So what you should be seeing is kind of this curve where it approaches 0, but never crosses it. So go ahead and get this down. If you have some questions, please ask.
I got it.
Okay. All right. So if your graph isn't very good or you're not comfortable with graphing, you can always use Desmos. I think it's a great tool. But now we're going to look at the graph of 2 to the x plus 4. Okay, so I'm going to bring down that graph and we're going to look at the new function here, 2 to the x plus 4. Now, because of all the work we've done, you should be able to already tell me what this plus 4 does. What does that plus 4 do?
It moves it up
Up how many?
4.
Yeah. Okay. Now, let's assume that you didn't know that, or we'll just work on this table approach here. We're gonna put these numbers into the function. So it's for 1, when x is 1, it's 2 to the 1 plus 4. Okay, so that's 2 to the power of 1, which is 2, plus 4, and that's 6. Okay.
Okay.
All right. How about the next one here? What is 2 to the power of 2 plus 4?
8.
8. You do the order of operations first. Then 2 to the power of 3 plus 4. What is that?
12.
12. Very good. And then if we do 0, it's 2 to the power of 0 plus 4. And now you know that anything to the 0 power is 1. 1 plus 4 is 5. And then that last one there, 2 to the minus 1 plus 4, it ends up being 4.5. Okay. Now, I'm just gonna move these off to the right here for the moment, and I'm gonna bring down this other table that we just worked on. And I want you to tell me, what do you see? I know there's a lot here, but so I'll try and highlight it. Um, Actually, that's in the wrong place. Let me move it in the other different place. Sorry about that. Let's move it over here to the left. Move this one here. See a little spacing. Okay, so how is this 1 and this 5 related? How do you go from 1 to 5? And if you're not sure, how do you go from 2 to 6?
It's adding 4.
Adding 4, right? Like you told me that from me. You're like, hey, it's adding 4. Well, the adding 4 only affects the y values. So notice that the 4 on the left here, so it goes up by 4 to 8, 8 goes up by 4 to 12. So we actually didn't need to do this on the right. You could have just moved every point up 4. So there's always a few options. Like the more math you take, the more options you'll have. 0, 5 here, 1, 2, 3, 4, 5. Okay, 1, 6, 2, 8, and then 3, 12. So this one's not on the graph, kind of like that. And then minus 1, 4.5. So this graph kind of, you gotta be really, are you more of an artist?
Kind of.
Kind of. Okay, so you can rate my graphing skills. You can say they're awful. But you want to at least show a nice smooth curvature to this. Don't give me, straight lines in between there. There is smoothness to the curve there. So the last part here, the last part, how do they differ? Well, you already answered that. They differ in that the blue, the second one, is 4 units up. It's transformed. You can say it's transformed or shifted 4 up. There you have it. So I think that covers everything in those problems you just sent me. Nope, I'm sorry. I didn't. There's a bunch now. Okay, so that's kind of the slow way to do all of them. The fast way would be to go out to like a Desmos and graph them, since you already know what the transformations are. We'll try and do this faster here for the next one. So is the next one on your list 2 to the x minus 3?
Um, yes.
Okay. So try and do this faster here because I'm sure you want to get all these done. And by the way, are you in Algebra 1 or Algebra 2?
Algebra 1.
Algebra 1, okay, because that stuff we were working on yesterday or 2 days ago was Algebra 2 material. So a little surprised. All right, so the 2 to the x, okay, we can reuse the points from last time. Okay, so if you go back up to our previous problem here, we have all the points. Like we don't need to redraw or remake a table. It's 0, 1, 1, 2, 2, 4, 3, 8, like that. So nice smooth curve like that. And instead of making a table, what you can do is you can actually just go point by point. So this first point here on the 1000 blue, we're going to move it where? Where are we going to move it?
To the down.
Down 3. So we just move that point down 3. 1, 2, 3, and put a dot. So this is another way to do it. You don't have to make a table every time. We're going to go down 3. So down 1, 2, 3 from each point. Down 1, 2, 3. Down 1, 2, 1, 2, 3. Got to be able to count. And There's even one more point there. So you should get something like this when you're done. And then you can use the same language. Did it go up, down, left, or right? Well, it moved down 3.
That makes sense.
Yeah, so give me some feedback here. Does this seem difficult? Do you feel more comfortable with it? What are you feeling right now about these problems now that we've looked at a couple together here?
Like the beginning, I was kind of confused, and then I started to like figure out the deal with the it's up down, and
Yeah,
how how to recognize the what I was asking.
exactly. You recognize it and you're like, oh, I know what to do. I don't feel so overwhelmed by this. Okay. All right, so I want you to tell me what this transformation is in this problem, please. New problem here.
That would be the right two.
Right, too, yeah. Okay. And since the parent function is the same for all of these, your graph is the same for all of them. So it was 0, 1, 1, 2, 2, 4, 3, 8. And then we just said minus 1, 1.5. So once you have those points, it's pretty easy to now know what to do here. You've got to go right 2 on each of those points. So this one that's at 0, 1, you just literally count and move to the right 2 units.
Yeah.
2 units to the right. Go to the next point, 2 units to the right. Go to the next point, 2 units to the right. It gets a little harder when they're fractions. So you just do the best you can. And they do kind of, it's hard not to draw them where they don't intersect, but they kind of shouldn't. But you're not being graded on your graphing. It's more graded on, like, do you have the right appearance? Is one graph right of the other? And you probably need to like color code them. I'm not doing a good job of that, but you might want to indicate that, hey, that's the red one, and the one to the right is the blue one.
Okay.
All right, so we got one more here. Now, you're in person for school right now?
Yeah.
Awesome. Okay. Is all the homework online like this, or is some of it physical paper?
Sometimes when we do like reviews for tests, it's on paper.
Okay. Do you know if you have a test or a quiz coming up here in the next week or so?
I think there's one on Friday.
Okay. So we're meeting again. We're not done yet, but we're meeting again on Thursday. So if you get a review, or if your instructor doesn't give you one, maybe you could just ask, hey, like, get some extra practice in. You don't even have to mention that you're working with someone. Just say, I want to get some extra problems to help me. Be happy to help you work through those.
Okay.
So the first thing I'm going to ask you here is what is the transformation? I'll go ahead and highlight that again. What does this +3 in the exponent do?
Um, it's to the left 3 units.
Left 3, yeah. We say units because we don't know like the real context of this. We don't know if it has any physical meaning. So the units are, it's the best word we have. Again, I'll just graph that parent function here. I'm just going back to that original table each time, except that's not correct. That one is 3, 8, and then -1, like that, and just try to get a nice smooth curve. Okay. And then each point is going left 3. So start at the top here, go left 3, 1, 2, 3, left 3. Next one here, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then you just try your best to draw the right kind of shape with that.
Yeah.
Okay, any questions on that or anything unclear?
No, it's all clear.
Okay, we got a few minutes left here. We can, I can just come up with some problems, or if you can quickly get something else over to us, we can, or me, I can look at that with you. What would be best to help you?
I don't have any more problems.
Okay, so let me just give you a couple here real quick. These are just review problems. Let's say the parent function is 3 times 2 to the, actually we've already looked at that one, so let's make it up a little bit different. Let's go 4 times 3 to the x. Okay, and let's say in this first example, I want to know the transformations for this. There are 2 transformations. What are they?
To the right 2 and up 1.
Perfect. Let's look at another one here. Let's say the function is 5 times 3 to the x, and I want to know what transformations you've got here. What are the 2 transformations that you see?
Left 1 and down 4.
Perfect. Okay, very good. All right, now let's make a table. So let's make a table for 3 to the power of x. Okay. So here's x, here's y. I want you to give me the outputs for 1, 2, and 3. 1, 2, and 3.
So 1 would be 3.
Good.
2 would be 9.
Very good.
3 would be 27.
27. How about 0?
That would be 1.
Good. Now real quick here, off to the side here. So 3 to the negative 1 power ends up being 1/3. Okay, and here's why. 3 is really 3 over 1. Do you agree with that? 3 is really 3 over 1.
Yeah.
So this negative 1, it just tells you to flip the fraction. So when you flip the fraction, the bottom becomes the top becomes the bottom. And that's why it is 1/3. Now right here with it, let's say I wanted us to do y equals 3 to the x minus 2. Can you tell me how these y values change on the right here when it's minus 2? Is that up, down, left, or right?
That's down.
Down how many?
Down 2.
Down 2. So each of these y values goes down 2. So sometimes it's easier to start with the big numbers. What's 27 down 2?
25.
Good. And 9 down 2?
7.
Okay, keep going. 3.
1.
And 1 down 2?
Minus 1.
Good. We'll have to save fractions and stuff like that for next time. We're getting here to the end of our lesson here today. So I'm going to